Welcome and thank you for joining me in this lesson. So we are going to take a look here at parallel and perpendicular lines and discuss how their normals are related to each other. So for example, we have two lines here, L1 and L2. And these two lines are given to be parallel. The normals to each line will be perpendicular to the respective lines. So for line L1, the normal will be N1. For line L2, the normal will be N2. So what we want to look at is the relationship between the normals of these two parallel lines. So as you can see, if two lines are parallel, then the two normals will also be parallel. So two parallel normals or two parallel vectors must be scalar multiples of each other. So in conclusion, we're going to say that the normals of two parallel lines are scalar multiples of each other, which means we can write them in the form n1 equals kn2, where n1 is the normal to the first line and n2 is the normal to the second one. Now, if two lines L1 and L2 are perpendicular to each other, then their normals, N1, this is the normal to line L1, and the normal N2, which is the perpendicular to L2, would be perpendicular to each other as well. If two vectors, or two normals, are perpendicular to each other, it means that their dot product equals 0. So in the next example, what we're going to do is we're going to find the equation of a line that is perpendicular to this vector. And we have to determine the equation in slope and y-intercept form. So we will approach solving this problem in two different ways. Step number 1, write the equation. So the given equation is r equals, or xy we should say, equals 3 negative 6 plus s, where s is a multiplier, negative 1, negative 4. So this must be the direction vector. So what we want to find is the equation of a line that is perpendicular to this. So we're going to say, if I want a line that is perpendicular to it in the form y equals mx plus b, it means that I need to know or to find what the slope and what the y-intercept of this line are. So for the slope of this line, remember that if this is L1 and this is L2, we would like L2 to be perpendicular to L1. And we'll say that the slope of L2 can be found by using the direction vector of L1. So the direction vector here is negative 1, 4. So this means that the slope of this line would be the rise or the y value divided by the x value. So that would be 4. The slope of the perpendicular to it would be the negative reciprocal of 4, which equals negative 1 over 4. So in this case, when we're going to say that y equals negative 1 over 4x plus b, we still haven't found the value of b. But what we do know is that the two lines are perpendicular to each other, L1 and L2. If two lines are perpendicular to each other, they must have a common point. And since we're not asked for a specific line, we're asked for any perpendicular, then we can choose to draw the perpendicular exactly at the head of the direction vector here. So 3, negative 6. So we can use the coordinates x and y of the vector form of this equation and substitute them into the slope y-intercept of the perpendicular to it. So with x equal to 3 and y equal to negative 6, our equation transforms to become negative 6 equals negative 1/4 times 3 plus b. So negative 6 plus 3 over 4 equals b. So negative 6 times 4, negative 24 plus 3, negative 21 over 4 equals b. So therefore, we're going to say that the line L2 will be perpendicular to line L1, and the equation of the line L2 in y equals mx plus b form, or slope y-intercept form, will be negative 1 over 4x minus 21 over 4. And this will be the answer to our question. So Another method of finding that same equation will be by using the fact that the two lines are perpendicular. So the lines L1 and L2 must be perpendicular to each other. So I'm going to write the second method here. If two lines are perpendicular, then we're going to say that the direction vectors of these two lines must have their normals multiplied to give a dot product of 0. So we are going to say that if the line L1, and I'm going to bring all the information in here one more time. So this is what we're given and what we have to find. I'm going to have to resize everything. Sorry about this. This won't take a long time. Okay. Okay, here we are. So there goes our first method here. So what we are told in here is that we have this equation xy equals 3 negative 6 plus s negative 1 negative 4, and we want to create the equation in the form y equals mx plus b. So we're going to say we need the value of slope, and we can find the value of the slope by using the direction vector. I will call the direction vector here m2, and the direction vector here will be m1. So recall that, again, we had the line L1 and L2 perpendicular to each other. So if M2 has the coordinates A and B, then we're going to say that the dot product of their slopes, M1 and M2, or their direction vectors, would be equal to 0. So M1 is negative 1, comma, negative 4, and M2 is simply A and B. So the dot product must be 0. So let's dot product these two vectors. So we'll dot product the x's and then the y's. So what we get in here is A times negative 1, negative A, plus B times negative 4, negative 4B equals 0. So negative A equals negative 4B, which will give the value of B over A, divide both sides by negative A, and we get 1 equals 4B over A, or B over A equals 1 over 4. So that means that the slope of this line would be B over A, or 1 over 4. So that means that the equation now is brought to the form 1 over 4x. Sorry, that's a negative still. Negative 1 over 4x, and then plus the y-intercept. So if you want to find the y-intercept, again, we're going to follow the same strategy as we did in the previous method, so in the first method, and the solution will end up being the same. So we're going to have negative 1 over 4x and then plus b. So I'm going to write a note in here. So to determine b, use method 1. And here is, oopsie. This is going to be our number 1 method, and this is our number 2 method, right? So the rest of the process will be similar to the other one. Now, in the next example, which is the last example for this lesson, we have to reason about the equations of vertical lines. So we are told that the vector equation of this particular line is given by r equals 1/4 plus s 0, 2. So it seems that the direction vector is 0, 2. And here is the direction vector. As a starting vector, we have used 1 and 4. So the starting vector must have been this one here. So the line is drawn from the starting vector parallel to the direction vector, as you can see. So we want to write the equation in Cartesian form, or in the form y equals mx plus b, which means that we need to find the slope and we need to find the y-intercept. To determine the slope, we're going to refer to the direction vector of the line. So if direction vector is 0, 2, then it suggests that the slope must be 2 divided by 0, which is an undefined number. So if slope is undefined, it means that we have a vertical line. The equation of a vertical line is x equals a number. And in our case, the x value that we can derive from this particular equation is 1, and we're given a specific point, 1 and 4, but we know that this is the only x value that the function would have, so we'll say that the equation of this function is x equals 1. So this will be the scalar equation. So I hope this made sense, and thank you for watching. Bye for now.